Good afternoon. I hope you're having a wonderful day. Today we're going to take notes on, it's our second section of notes for Unit 8. It falls on day 6. The topic is solving rational equations, and I'm hoping it's a review for most of you. Rational equations are ones that have x's on the top and the bottom of the fractions. That's where that family gets its name. So I'm going to show you a variety of approaches on how to solve equations so that you have more than one way to do things. We're going to start easy and then go more challenging. If at any time I get ahead of you, please don't forget to pause the video, get caught up, and then restart it when you need to. You can also pause, review, and go back over a section you'd like to hear again. All right, so the first technique we're going to look at is solving by getting a common denominator. So when you're getting a common denominator, really what you're doing is you are obeying the equal sign absolutely. So to get a common denominator, first off, you want the lowest common denominator. If you go any higher than the minimum, many of the problems will not be solvable. You'll get stuck at the end. So for the lowest common denominator, you need to factor completely. Factor the denominators completely. And then you need to multiply by the missing factor over itself. Now this is legal because anything over itself equals 1. So you can do that at any time and you aren't hurting anything in the problem. So first thing we're going to look at is, can we factor any more? And this one's really easy because no, the bottoms are already factored. So now we're going to get the lowest common denominator on the left and the right. So the left one is missing this factor. So I'm going to multiply the bottom by 3x plus 1, which means I need to multiply the top by 3x plus 1. Now I'm going to do the same on the other fraction. It has a 3x plus 1. It needs an x plus 2. So I'm going to multiply by x plus 2 over itself. Okay, this is a step that you probably wouldn't show on your work, but I find that students that have difficulty with solving rational equations have issues with this step, so it can be really important. First, I'm going to bump the 3 up to the front for convenience. I'm going to rewrite this with some space on either side. 3x plus 1, x plus 2. Again, I'm just rewriting this because it's notes and I want you to see what's happening so that you can understand it and remember it long term. So now that we have a common denominator, we're ready for the next step in the process, which is to divide the, and we're going to say lowest common denominator, LCD, off both sides of the equal sign using reciprocals over 1. So what I'm going to do is I'm going to multiply the right-hand side by 3x plus 1 times x plus 2 over 1. Now this is not a factor over itself, so I can't just do this on the right. I have to do it equally to both sides. So I have to multiply the left by the identical same thing. 3x plus 1 times x plus 2 over a 1. And again, it's legal because I'm doing the same to both sides. Now, what you're going to find is that when you do this, the denominators on both sides completely cancel out or divide out, and what you're left with are the tops. 3 times 3x plus 1 equal to 2x. Times x plus 2. See how easy that is. Now we're going to finish solving. So distribute the 3. You get 9x plus 3. Distribute the 2x. You get 2x squared plus 4x. This is a quadratic, so we're going to need to set it equal to 0. So I'm going to go ahead and subtract the 9x to the right. Subtract the 3 to the right. I'm going to put my 0 on the left. So 0 equals 2x squared minus 5x minus 3. Now at this phase in the game, because it's a quadratic, you have a couple options for solving. You can factor to solve, you can use the quadratic formula to solve, or you can use completing the square to solve. You get to choose. Now, naturally, factoring is the fastest, so we really hope it factors, and this one actually does. 2x and x, negative 3 plus 1. Negative 6 plus 1 is a negative 5x. And then, of course, we're going to solve. And so we set each factor equal to 0, and we solve them separately. So this one is x equals 3. On this one, you have to subtract the 1 to the right, then divide by 2. You get negative 1/2. Okay, here is where, when we're doing rational fractions, we have an extra step. So I'm going to draw a little line here. And this is an extra step that is unique to quadratics. And the extra step is that you have to check for excluded values of x. Excluded values of x cause restrictions on the solution set. So in other words, there are some values of x that you're going to get through solving that are actually not values of x. They are restricted values. You can say restricted on the domain. You can say excluded values. Because they're excluded, because they're restrictions, we call them extraneous solutions. That's the big catch-all for everything. So how do we do this? Okay, so remember that no value of x can cause a 0 in the denominator. If it does, then that value is what we call undefined in the domain. It doesn't have a place in the solution domain. So what you do is you take your denominators, set them equal to 0, and solve for the restricted values. All right, looking at our original, we set x plus 2 equal to 0 and 3x plus 1 equal to 0. And we may or may not get restricted values. So let's solve this one. This is x equals negative 2. Subtract the 1 over. X equals negative 1/3. So if they ask you for restricted values or excluded values, your answer would be negative 2 and negative 1/3 are not allowed. Now, if you got either one of these as one of your solution values, your solution value is now invalid and it is called extraneous. So these are restricted values. Extraneous solutions are any of our solutions that turn out to be restricted. As it is, both our values are good. Those are the only two things it could not have been. Very important concept. Okay, so that is using a common denominator. This is actually the technique for solving that I recommend most often because it tends to defeat most of the silly mistakes that happen when we're solving problems of this length and complexity. Okay, Roman numeral 2. This is the technique a lot of people like, but it tends to not go that well unless you do it correctly. Cross multiplying to solve. So we're going to do an example. Let's see. X plus 1 over x minus 5 equals 0. So cross multiplying to solve is a way of canceling out the bottoms of the equation without writing out the common denominator step. So equal to 0, it's a little bit harder to see. So I'm going to subtract the x over. And I'm going to put the x over its invisible 1 to help you out. So basically, when you cross multiply to solve, you look for factors you want to cancel. You want to cancel out. Look for factors you want to cancel out. And then you multiply both sides. Again, it has to be both sides by those factors over 1. So I want the x minus 5 to cancel out. So I'm going to multiply the entire left by x minus 5 over 1 and the entire right by x minus 5 over 1. Every term on both sides must be multiplied by the same thing or it is invalid. So this will cause the left one to cancel. But on the right, there was nothing to cancel out, so you have negative x times x minus 5. And this is why this technique is not one of my favorites, because it tends to cause students to miss terms or skip over terms or cancel things that aren't canceling. All right, let's finish this out. Distribute the negative x, so negative x squared plus 5x. This is a quadratic, so I'm going to move everything to the left. So add the x squared to the left, subtract the 5x to the left. You get x squared minus 5x plus 1 equals 0. Now this one does not factor. It is a quadratic though. But factoring won't work. You're never going to get a 5 out of a 1. So we're going to use the quadratic formula to solve it. So x equals negative 1. And if you don't remember, a is 1, b is negative 5, c is 1. I'm hoping you can remember your quadratic formula. But if not, x equals negative 1 times b plus and minus the square root of b squared minus 4ac, everything over 2 times a. All right, so here we go. Negative 1 times b, which is negative 5, plus and minus the square root of negative 5 squared minus 4 times 1 times 1, all over 2 times a, which is 1. Okay, let's simplify. You have a positive 5 on the top. You have a 2 on the bottom. So this is 25 minus 4, which is 21. So this is 2 separate answers, but it is correct. Now we need to check for restricted values. Restricted or excluded values. And they're excluded from the domain or they're restricted from the domain. So the only denominator in the question that has an x in it is the 1 over x minus 5. So we're going to take x minus 5, set it equal to 0, and solve. So x can't be positive 5. That's a restricted value. But since we didn't get 5 as a solution set, our solutions must be good. All right, so those are your 2 basic techniques. Now we're going to do some more complicated problems. We won't go all the way through them, but we will go through the most difficult steps. So this is Roman numeral 3. We're going to call this multi-step solving. And this is where using good technique really pays off, because if you're using good technique, then you're able to solve complicated problems without breaking a sweat. So 2x over x minus 1 plus 1 over x minus 3 equals 2 over x squared minus 4x plus 3. Okay, so we need to solve for x, so we need to get x out of the denominators. To do that, we need to find the lowest common denominator, which means you have to factor all of them as much as possible. So this first one's easy because x minus 1 is factored. X minus 3 is factored. On the second one, it's going to be x minus 1 times x minus 3 because negative 3x minus x is negative 4x. All right, so now that you have it factored, we want to get the lowest common denominator. So we're going to multiply each of these by the factors they're missing until the bottoms match. So this first one is missing an x minus 3. The middle one is missing an x minus 1. The right-hand one already has both. So now all three of these match. Okay, again, the next step is not one you would normally write, but this is notes, so we're going to write it in the notes. So we have 2x times x minus 3 over x minus 3 times x minus 1 plus x minus 1 over x minus 3, x minus 1 equals 2 over x minus 1, x minus 3. That's what we have so far. So here is the money move. To eliminate the denominators, you're going to multiply by the lowest common denominator over 1 on both sides. So I'm going to take this entire left and multiply everything by x minus 3 times x minus 1 over 1. And I'm going to take the entire right, multiply it by the same thing. Sorry, that's getting a little small. That takes up some room. So on the left, when you multiply this times the first fraction, it cancels out. But remember, it's being distributed. So when you multiply it by the second fraction, it cancels out the bottom. So all you have left is 2x times x minus 3 plus x minus 1. On the right, there's only one term. Everything divides out, so that equals 2. And from there, you would finish with the quadratic formula. And we're not going to finish this problem. We do, however, want to pause for restricted or extraneous values. So ultimately, this factored into these two. So really, I only have two different denominators to worry about, not three. So I'm going to take x minus 1 equal to 0, x minus 3 equal to 0, and I get that x cannot be 1 and x cannot be 3. By the way, on the graph, 1 and 3 would be vertical asymptotes or holes, because those are restricted values. They are values that x cannot be. Okay, last one we're going to go over today. And again, I'm just going to do the salient parts, not the entire problem. This one is x minus 3 over x minus a negative 3 over x plus 2 plus 6 over x squared plus 2x equals 0. Now, first thing I want to draw your attention to is this subtraction. All kinds of weird stuff happens with subtraction. The subtraction symbol only applies to the top of the fraction it's in front of. So that negative applies to the top. So if you look at your problems on your worksheet or in the book and it's got a negative in front of it, when you go to write the problem down, go ahead and replace that with a positive and distribute the negative to any terms that are up there. In this case, there's only one. But if there's more than one term, like if it was in front of the x minus 3, you would have a negative x plus 3 because it would get distributed twice. But yeah, get rid of the subtraction. All it does is mess with your math. Now this factors into x times x plus 2. So get rid of the subtraction. That's one of the The biggest places for errors is right there. I can almost spot it. Okay, so now we're going to get a common denominator. So the first one has an x, it needs an x plus 2. The second one needs a single x. The third one has everything. And this is probably more like your work is going to look at home. So you're going to take, and now that you've got a common denominator, you're going to multiply, oops, that should go clear over there. You're going to multiply everything on both sides by the common denominator over 1. Over here, same thing, by the common denominator over 1. And what happens is all of the denominators cancel out and you get the tops. X plus 2 times x minus 3 plus 3x plus 6 equals, and of course this times 0 is 0. Okay, so let's finish this out. Multiply those together. So x squared, and I'm going to take a little shortcut here, minus x minus 6 plus 3x plus 6. Simplify. The 6's add up to 0, so we actually get x squared plus 2x equals 0. It is a quadratic, but it does factor. X and x plus 2. So what we get is this one set equal to 0. This one set equal to 0. So we get 0 and negative 2 as our values. Now let's go back to the original and let's check for those restricted values. So this x, when you set it equal to 0, this x cannot be 0 or you're dividing by 0. When you set x plus 2 equal to 0, x cannot be negative 2. So 0 and negative 2 are not in the domain, so they cannot be solutions. Now, we got a 0, so that is now extraneous. We got a negative 2, that is now extraneous, and there's nothing left. So this is a no solution problem. Now, on some of your questions, when you're done solving, they're going to ask you to give the domain of the problem. So we know that our domain can't have 0 or negative 2 in it. So this domain would be negative infinity up to 0 in union with, so not including 0, 0, oops, I put this backwards, sorry. Let's try it again. Negative infinity up to negative 2 in union with negative 2 up to 0. All these are exclusive. In union with 0 up to positive infinity. So your negative 2 and your 0 would be holes in your domain. They would be things that x cannot be. The restrictions exist regardless of whether you're solving or graphing or giving domain. These restrictions are still there. They stand alone in that they are values that x can't be. So it doesn't matter what problem you're doing, these are still going to be restricted values. Whether you're graphing, solving, doing domain, they're still things that x cannot be. They're vertical asymptotes or they are restricted values. All right, I hope that was a good review and that you have a great rest of your day. We're all done.